Let me get this done. All right, so we're gonna take the derivative of log now, and the thing with log, just want to kind of show you, this was a natural log here, but natural log is simply log base e. If you take a regular log, I have the ability to change the value of b. Right now b is 2. All that happens as you change the base is that, you can see that, it kind of compresses it. 10 is usually the common log, so if you don't see a base, it's usually 10. Well, it is 10, not usually, it just is. So we have here the picture of a log, just so you understand what we're taking the derivative of, and we're going to keep b as a placeholder. It sort of just means, all right, we're going to generate a formula for any base b, not just base e like the natural log. And we are going to go ahead and take the derivative, but in order to do that, I'm going to change it back to exponential like I did previously. So it would be b raised to the y is equal to x. So I have b to the y is equal to x. Keep in mind, b is supposed to be some number. We're going to go ahead and take the derivative of this so what we're going to do is we're going to take the derivative of b to the y. Now b to the y is going to follow the same thing as the previous video where we had a to the x. Its derivative was a to the x times the natural log of a. And then if there's anything to take the derivative of in the power, you multiply that here for chain rule. So let's do the derivative of this guy in terms of x. Alright, so one more time, we're going to take the derivative in terms of x. So that's going to require implicit, but we're going to use what we already know about exponentials. So the derivative of b to the y is b to the y times the natural log of b. So that's the derivative of the b to the power part. And now the derivative of y is going to be dy dx. And the derivative of x is 1. And so remember, natural log of b is just a number, and b to the y is the function times dy dx. So we're going to divide this whole thing by b to the y times natural log of b. And we're going to do the same thing to the other side, b to the y times natural log of b. And so what happens is that dy dx is going to equal 1 over b to the y natural log of b. Natural log of b, remember, is just a number. So b to the y, well, what's that? Well, earlier we said that b to the y was x, so we can replace this with 1 over x, which is similar to the natural log derivative, but we have to add one more piece, natural log of the base. Okay, so in general, the derivative in general would be the derivative of any base of, log base b the derivative of log base b of u, so u meaning any function inside of it, will equal 1 over whatever's inside, which is u, but you have to add one more piece, times the natural log of the base. And then if it's anything other than x inside, you have to multiply by the derivative of that something. So let me show you an example, because that always clears things up. Let's say we had y is equal to log base 6 of 4x. The derivative of that would simply be 1 over the 4x times, and that's in the denominator, the natural log of the base, which is 6. So that's the formula for the derivative of the log base 6 part. And then we're going to multiply that by the derivative of the inside, which in this case is 4. And we're going to simplify the 4s, getting that y, the derivative of y is x. Excuse me, that is not right. It's 1 over x times the natural log of 6. Sorry about that. And then that's it. So we're going to practice all these in class. Your job is to memorize the formulas for x. Drill and skills check on Friday. Keep that in mind. All right, so shout out to Jesus Lopez, who asked for a shout out in the videos.